Okay, welcome back, guys. Let's keep talking about functions. Okay, just a quick recap. Last time we said that a function was basically just a machine. Poorly drawn function machine. Okay, that we throw things into it, and what we put into it, we said those were inputs. So put things into it, and we get out output. Okay. And then linking this back to our idea of linear equations. In a linear equation, your input was your independent variable, most of the time the x variable, and your output, in terms of a linear equation, was just the dependent variable, usually y. Okay. So today we are going to give the formal definition of a function. Okay, the sort of formal mathematical definition, and it is very sort of abstract, but I guarantee you it's one of the most sort of applied things in math. Like I was saying last week, we're going to be using this for we're going to be using the idea of a function for a long time. So let's go ahead and look at a set of data. Okay, we're going to go back to sort of the problem that we did last week. Okay, so check out the left table. Okay, this is basically just a photocopy of the data set from the last lesson, of the object sort of falling through space. Right, it got dropped from a distance of 256 feet, and it hit the ground exactly 4 seconds after being dropped. So let's look at that first table, the one on the left. Okay, so how far does the object fall in the first second? All right, so remember from last time, to figure out how far it fell during a given time interval, we just need to take the distance that it had fallen at the end of the time interval and subtract off the distance where it was at the beginning of the time interval. Okay, so after 1 second, it's fallen 16 feet. The distance it had fallen at the start of the time interval, so it just says in the first 1 second. So that means we're going from the beginning of it being dropped to 1 second later. So at 0 seconds, it hadn't been dropped at all. So 16 minus 0, so that gives us that in the first 1 second, it dropped 16 feet. Okay. Now, can you answer that same question about an object falling that follows the data set in the table on the right? Well, we need to, so in the first 1 second, we need to figure out how far it fell after 1 second, so let's go ahead and do that. Well, boom, right there we run into our first problem, okay? Because the table tells us that after 1 second, the object has traveled, 4 feet, but it also says that the distance has traveled 36 feet in 1 second. So which one do we use? So we asked one question about these two data sets, and after the first question, we ran into trouble with the second one. So what I want you guys to ask yourselves now, and see if you can answer this, is, so which table is going to be more useful for us in terms of making predictions? If we want to make a prediction about where something is at, which table sort of has more regularity, or even, is it telling you one thing throughout the table, or is it telling you, like in the second table, like in the table on the right, it's telling you one thing, but then immediately after that, it's contradicting that thing, okay? Like, how can something, like if I drop this marker, right? Like after 1 second, it was where it was at, right? It couldn't be here and here, or here and here and here, right? It can only be at the one place at any given time. So if we want to be able to use these data sets to predict anything, so use them as a function, they got to be useful to us. They have to tell us useful information. And we're going to see here in a second how the one on the left actually follows the sort of stipulations that are required for a particular data set to actually be a function. Okay? And the one on the right, it actually breaks some of the rules, and so we'll see that it cannot be a function. So last time we defined a function to be a rule that assigns to each value of one quantity one and only one value of a second quantity. If we look at the table on the left, so each sort of value in the sort of list of for the x and the y, I'll call it. I might start calling it the list of inputs, and the y's I'm going to call that the list of outputs. So if I say that, just know that I'm just talking about x values and y values. So x values are inputs, y values are outputs. So look at the list of inputs, or x values. Every single one of them has a value. Actually, in both of the tables, every single input has an output. Okay, great. That's sort of rule number one. Well, rule number two says that for each input, there can be one and only one output. Okay? So in the first table, so 0.5, okay, it only has the one output 4. 1 only has the one output 16. Okay, but let's look at the table on the right. Well, 0.5 does only have the one output 4. 1 has an output of 4, and you may think to yourself, oh, hey, look, two outputs that are the same. So that's actually totally fine. Just like in the example from last time where we were dropping something. Well, at 4 seconds, right, it sort of hit the ground. But time still keeps going, right? So you could say that it has gone 256 feet at 4 seconds, but what about at 5 seconds? Well, it's still sitting there on the ground, right? So it's still only gone 256 feet. So, there can be the same output for several different inputs, but you can never have more than one output for the same input, okay? So like here in the table on the right, the input of 1, it gives you an output of 4, but it also gives you this output of 36, okay? And that is just simply not allowed. And that is something called the vertical line test that you guys are going to learn about more a little bit later.